Welcome to our WellCAD video series. Today we will be talking about the new features in WellCAD version 5.5. The features covered in this video are improvements made to the image and structure interpretation module ISI, the revision of the data import process for borehole imaging tools, the Flowmeter calibration and data processing improvements, and the new script editor in WellCAD to handle and execute VBS scripts. I'm starting with a borehole document containing some image data, the amplitude image from an acoustical televiewer and the image from an optical televiewer. I would like to pick these features using my ISI workspace, which I have created before. So I'm going to open it with a double click on the Explorer bar. In the ISI workspace, I'm scrolling down to the depths where I would like to continue my work. And I would like to fit a sinusoid to that open feature that we can see in our ultrasonic televiewer image. Holding down the Shift key, left clicking once, left clicking twice, I fit a sinusoid. Holding down the Shift and Control key, I'm now able to measure the aperture of that feature. If I would like to see the aperture value, I can either have a look in the status bar, or I can open the tabular editor for my apparent pix log. With a right click and going to the editor, I can see that this feature has about 16 millimeter of an aperture width. Sometimes it is necessary to provide aperture instead of absolute values in class codes, so an aperture class per value range, and how to add this column. This is a new feature in WellCAD 5.5. To add an aperture classification, have a look at the workspace settings in your properties bar and you will find an aperture attribute entry. Left click on the options button. You see that you can fill in a table with categories or class names and value ranges. You can load these categories by clicking on the load button and bring in a tadpole dictionary that you can create in CodeCAD. It will provide you with the class codes as well as some symbols. Once you have set up your value ranges, just click on OK. Have a look at the classification bar and you will see your imported aperture symbols and the value ranges assigned to it. What will happen if you change your aperture now? Holding down the Shift and Control key, and I widen this up, and you will see how your category changes automatically according to the logged data value. Let's move on and pick some other features. For a long time, we have been asked to pick partial events, partial sinusoids. So if I would like to pick something that we see down here in the lower part, I have to fit a full sinusoid as usual first. Then I'm going to hold down the P key on my keyboard and I can set the endpoints of the visible part of that sinusoid coming from left to right and setting the start and the endpoint. Let me apply a classification to that feature so we can see this a bit more clearly. So we are still showing a full sinusoid, but the visible part is a solid line and the non-visible part is a dashed line. If I have a look at the tabular editor now, how these features are recorded, open the tabular editor again, we will see that we're recording beside the feature depths, which is the depths of the visible part, and the depths of the sinusoid, still the azimuth and the dip angle derived from the full sinusoid. We are also recording the visible arcs of the starting point and azimuth, here about 182, it's extending to 316 degrees, and as usual, the type, and in our case, also the aperture class. Let me repeat that process at another position there so that you see it also works with open features. So the first thing that you have to do is fit a full sinusoid. So I'm going to pick this event down there. Here I'm opening it up, Control Shift and drag. Now I'm holding down the P key on my keyboard and I select, coming from left to right, the starting point and the end points with a single left click. And what I will see is the visual part. What I'm recording is the feature depth, which would be the midpoint of the visible part, and a depth which is still the inflection point of the full sinusoid. Next, I'm going to introduce a new log type, the lineation log. Lineations are line or vector-like features intersecting the borehole. Some popular examples are mineral lineations or deformation lineations, such as a fold axis. Our data sample shows a fold and it's limbs right here. Let me rotate the 3D log to see it a little bit better. Here we go. And the axis will be right here. And it's the orientation of this axis that we're going to pick now using the lineation log. First thing I have to do is leave my planar feature picking mode and switch to lineations. I'm holding down my Shift key and I set one intersection point of that lineation, and with the second click, still holding down the Shift key, I'm setting the second point to enter the axis. So I'm flagging this as a fold axis, should be selected, fold axis, and I'm rotating my 3D log to show actually the orientation of this axis. If I have a look at the tabular editor now, I'm right-clicking on lineations and editor, we will see the type of data that has been recorded. It is a depth, it is the trend or the direction of the azimuth, a plunge comparable with a dip angle, an eccentricity, and my custom classification of the feature. Let's assume I have completed all the picking using the easy workspace and I would like to push my data back to the borehole document. You simply click on the export log icon and you will see the next improvement we added to WellCAD version 5.5. In the past, each time you pushed data from the easy workspace back to a borehole document, a new log was created. Now you can actually make an assignment between your answer product and an existing log in your borehole document, and the data will be either overwritten, or if you remove that checkbox, it will just add it to the already existing data. So I click on OK to perform that step, and I close my easy workspace. The data has been added to my borehole document, and I see my partial picks. I see my lineation pick over here, and I have created a polar projection plot with some contour lines. Another feature we added to the 5.5 version of WellCAD is the application of a Terzaghi correction whenever we derive statistics from structural data. In this case, I would like to apply the correction to our contour plot. To do that, I'm selecting the log title of the polar and rose log, move into the properties where I will find the Terzaghi correction. I click on the options button and I get a dialog box where I can apply the correction. If you would like to learn more about the Terzaghi correction, remember that at any time you can press the F1 key on your keyboard to jump into the context-sensitive help system of WellCAD. In our case, I just click the OK button to apply the correction to our contour lines. You can also apply the Terzaghi correction when you run the structure interval statistic process located under Process, Easy Module, Structure Logs, Structure Interval Statistic, and you will find an option to apply the correction right over here. In the past, we used the FMS FMI wizard to handle this task. We replaced this tool with two new processes located on the process LIS module. One of them allows the input of all logging specific parameters, such as the number of pads, the sensor button configuration, or the sensor position relative to the pad reference point. A second dialog box allows us the input of data source specific parameters. Since channel names, units, and orientation references change more frequently than the characteristics of the logging tool itself, we decided to go for two separate dialog boxes. Besides specifying the input channels for my data, or do last-minute fixes like changing the button configuration, apply offsets, I can gain confidence in my processing results by looking at this preview. Once you're happy, just click OK to commence the processing. The next topic we would like to look at in this presentation is the calibration of spinner Flowmeter tools and the flow velocity process, which makes use of the obtained calibration model. The data I have opened in this WellCAD window shows us the spinner frequency as well as a cable speed for a down and an up run over a no-flow zone. For calibration purposes, we will recommend to provide spinner frequencies for 3 different logging speeds. In this example, the speed was successively decreased, respectively increased, but it would perfectly be okay if you can provide the data in individual runs. To start the calibration workspace, open the Tools menu, go to Flowmeter Workspace, Calibration, and New. WellCAD will attempt to detect the log titles of the corresponding cable speed and spinner frequency pairs automatically. If this fails, or if the calibration data is spread over multiple borehole documents, simply click into the cell with the log title, extend the drop-down list, and select your entry. Once this is done, click OK to open the calibration. The calibration workspace contains 3 parts: the properties on the right, 2 tracks showing all cable speed and spinner frequency curves, along with some automatically detected zones. These zones can be edited, can be shifted, can be deleted, or new zones can be created. On the left, we have the calibration crossplots, which shows average values derived from each calibration zone, plotted on the line speed versus spinner frequency axis. A linear regression will be performed for the data from the down run and the up runs individually. The relationship between spinner frequency and velocity is shown in the info boxes next to each regression line. The intersections of regression line and line speed axis provide the threshold velocity of the impeller. It can be read from this info box in the crossplot or from the properties. Now, in this particular case that the velocity of the flow is 0, we can detect that the threshold velocity for this system is asymmetric. The final calibration model and all the calibration data is stored within the workspace. I can close that workspace at any time, and the information will be saved as soon as I save my borehole document. I can replace all calibration data with a new set of data and create a new calibration model without losing the data and the calibration of the first workspace. In order to use the calibration model for a run over the flow zones to calculate the flow velocity, ensure the borehole document containing the model is open and load or open your logging run. From the Process menu, select Common, Groundwater, and Flow Velocity. In the Flow Velocity dialog box, we can select our calibration model and the input channels for spinner frequency and logging speed. A correction factor can be applied that takes the position of the spinner flow meter in the borehole into account. If you would like to learn more, feel free to press the F1 key and access the manual. If you can provide information about the borehole diameter, a volumetric flow rate in cubic meter per hours, or other units can be computed. The checkbox at the bottom allows us to extract the crossplot from the calibration model and place it in the borehole document header. Clicking on OK starts the process. The output of the process in this case is the flow velocity in meter per minute and the flow rate in cubic meter per hour. And if we scroll up, we will see that the calibration crossplot has been added to our borehole document header. The last topic of this presentation introduces the integrated script editor, which is part of the WellCAD automation add-on module. For many years, WellCAD provides a syntax of objects, methods, and properties that allow access of documents, logs, and processes in WellCAD from program code written in Visual Basic, Visual C++, or Python, just to name some of them. Known for its simplicity, we decided to use Visual Basic Scripting, or VBS, to be used in the editor, but an extension to Python is already planned. Using the amplitude and travel time raw data from an acoustic televiewer, I would like to demonstrate how routine tasks like correcting bad traces in the image, application of filters, or renaming logs can easily be automated using a few script lines. Let's start the editor first. From the View menu, select Toolbars, and then Script Editor. To start a new script, click the New Script icon, and by doing so, WellCAD will add the necessary lines of code into the script window and gives us access to the WellCAD application. Now that I have a handle to my WellCAD application, I can use the object browser on the right-hand side to see which other methods and properties are available in the application object. For instance, I double left click on Get Active Borehole to get access to the currently displayed data. Using the provided handle, I can now check in the borehole document and choose processes like the one from the image module to correct my bad traces. Again, I just double left click, and this method takes a parameter which is simply the log title, which I can copy and paste right into the code window. Or if I repeat this step for the travel time log, I just double left click to add the method, copy the log title, and here I paste it straight into the properties window in the object bar. At the next step, I would like to apply a filter to my travel time log. Again, I just double left click on the corresponding method name, here filter image log, in the object browser. I paste the log title, and here I have an option to select the type of filter I would like to apply. Looking at the code line that has been composed, I see that a new object is returned, which is a so-called log object. And using, for instance, the name property of the log object, I can easily rename this log. into travel time filtered, for example. I'm going to execute this script now by just clicking on the little run icon. And done. We will see the correct bed traces has been applied, a filtered travel time log has been created, and the log has been renamed. You can certainly save and reuse the script for similar datasets or extend its functionality using the many methods and properties provided by the automation module. I hope you liked the short introduction to the highlights of WellCAD 5.5. Many more features have been released, and in case you would like to learn more, please visit our webpage.